In this video, we're going to continue working on the chain rule with more chain. In our first example, y equals natural log of sine of root x. We have the inside function is sine root x, which will be a chain rule on its own. The outside function is natural log, so dy dx is equal to 1 over, don't change the inside, so sine of root x. Now we have to take the derivative of sine root x, which is a chain rule. So we have the derivative of sine is cosine. Don't change the inside. Multiply by the derivative of the inside, which would be 1 over 2 root x. We can simplify a little bit. We have dy dx is equal to cosine root x over 2 root x sine root x. We might like to see that as cosine over sine being cotangent, so we could do cotangent root x divided by 2 root x as an alternate answer. In number 2, y equals secant to the 4th power, 3x squared minus 2x. So let's think of that instead as secant to the 4th power, since that means the same thing. So our inside function is secant 3x squared minus 2x. So derivative of the outside would be 4 to the 3rd power. Don't change the inside. Now we need to do the derivative of the inside. The derivative of secant would be secant tangent. Don't change the inside, so 3x squared minus 2x, 3x squared minus 2x times the derivative of that inside. So the derivative of 3x squared minus 2x would be 6x minus 2. That's a pretty nasty looking problem there. Thinking about how they could simplify that, I suppose we could bring that up into the front. We could distribute the 4 if we want to. And of course we could bring that cube back to its original spot. So one possibility would be 24x minus 8 secant cubed 3x squared minus 2x multiplied by secant 3x squared minus 2x tangent 3x squared minus 2x. Next problem. So we have find dy dx. Y is tangent squared sine root x. Again, I would think of that by moving the square out. Our inside function would be tangent of sine of root x. So we have dy dx is equal to 2 tangent sine root x times the derivative of the inside. The derivative of tangent would be secant squared. Don't change the inside. Multiplied by the derivative of the inside. The derivative of sine is cosine. Don't change the inside. Multiply by the derivative of the inside, 1 over 2 root x. We could cancel out the 2 in the front with the 2 in the back, and I would imagine that AP would write that as perhaps tangent sine of root x secant squared of sine of root x cosine of root x all over